we are starting the kinematics for the AS Physics 9702. So I hope so that you all are feeling very great by listening that we are also starting the A levels physics. So this is the kinematics. As usual, we have already discussed in the O levels. But as you know, in A levels or the advanced level, there is an extension of the syllabus or extension of the knowledge. So something are new in the kinematics, such as the formulas, the new formulas. But do not worry, these are the formulas derived from the formula you have already acknowledged in your O levels. So start equations of motion. So these are very familiar to you as distance, displacement, speed, velocity, acceleration. First of all, quickly just read out this. What is distance? The distance traveled by an object is a scalar quantity and describes the amount of ground the object has covered. Displacement, the overall distance traveled from the starting position includes the direction. So quantity. Speed is the scalar quantity which describes the direction traveled per unit time. Velocity is the rate of change of displacement as it is shown by the delta s upon delta t, where the delta s means the change in displacement upon change in time. Acceleration is the rate of change of velocity, where the delta v upon delta t means that the change in velocity upon change in time. So this is nothing new. I hope so that this is very clear to you guys. And if you require more of the knowledge that you does not understand this, so okay, so if you does not understand this, so you can go towards kinematics O levels where I have in detail described these are terminologies. Okay, now just focus on the graph, which is very essential for your A levels. As you can see now, this is the acceleration time graph, and in this you can see that the red line shows you the straight line of uniform acceleration. And how it is uniform? Because it obviously it is a straight line, so it is represent as a uniform acceleration. What does the uniform acceleration mean? So non-uniform acceleration means, as you can see, that the acceleration is increasing, means it is not at constant. Okay, so the blue line shows you non-uniform acceleration, where the area you can find out by the delta velocity. How can you just find out the area by delta velocity? Is that okay? Uniform acceleration is where the acceleration of an object is constant. Meanwhile, here you can see that the uniform acceleration is constant or uniform. Okay, this is the terminology of the physics you have already discussed in the O levels. Acceleration time graphs represent the change in velocity over time. Therefore, the area under the graph is change in velocity. As you see in the acceleration definition, the rate of change of velocity is equals to delta v upon delta t, where the delta t is shown you and acceleration is also shown you. So you are required to find out only delta v, which means change in velocity. In the second, you can see velocity time graph where you can see the uniform acceleration. So how can you consider this line of purple as uniform acceleration? How it is constant acceleration? Can you see from the formula? You can observe this from the uniform acceleration is because you can see that the velocity is continuously increasing. So what is the definition of acceleration? Is that the rate of change of velocity. It is when the velocity will be changing continuously, it means that the acceleration is uniform or constant. Okay, and it is non-uniform or is not constant when, as you can see in the diagram number 3, that the acceleration the velocity is now becoming the gradient is becoming steeper and more steeper. It means that the velocity is having velocity now is not increasing, and you cannot just see that it is increasing either in slowly but it is not increasing, so it is non-uniform acceleration or is not the constant acceleration. Okay, just to focus on the second graph. As you can see in the second graph shown to you is the area is equals to displacement. How can you say to find out this region, blue shaded region, as area is equals to displacement? How can you just say it? Can you just see the velocity time graph or the formula as a formula? Velocity is equals to delta S upon delta T, where delta S means displacement. As shown in the definition of displacement in the bracket small s, it means that this is a symbol for displacement used by the examiner many times in the question paper. The delta T means time. So the time is given to you, velocity is given to you in the graph. You can easily find out the displacement. Okay, velocity graph represent the change in velocity over the time. Therefore, the gradient of a velocity graph, velocity time graph is acceleration, and the area under the graph is displacement. Okay, displacement time graph show the change in the displacement over the time, and so their gradient represents velocity. Okay, instantaneous velocity is the velocity of an object at a specific point in time. Okay, so do not mind the wording. It can be found from a displacement time graph by drawing a tangent to the graph at the specific time and calculating the gradient. Okay, what is tangent? Tangent is basically the line. We will also understand this in the maths chapter of the angles and properties of circle, where the tangent is basically a straight line which does not interfere inside the circle but is touched towards the line of the circle or the ends of the circle. I know that there is no corner of the circle, but what I mean to say is that when you draw a circle from the line, so you also require to make a tangent, meanwhile a single straight line which touch the circle, does not touch or interfere inside the circle or having any gap, no. So this is called the tangent. Okay, we'll also understanding this very clearly by showing you that how to make the tangent. So do not worry. And displacement time graph shows you the velocity. Obviously velocity is equal to distance upon time. Distance and speed can be represented in distance time graphs and speed time graphs respectively. Note that unlike displacement and velocity, distance and speed will never be negative as they are scalar values. You can also consider that the scalar values cannot be negative. Okay, this is the point you can note in your books. In order to derive the, okay, now this is very essential for you guys. In order to derive the uniform acceleration equations, you must consider the following velocity time graph of a uniformly accelerating object. In the graph below, you can see the velocity time graph is shown to you where the initial velocity and the time region show you a triangle, oh sorry, a rectangle, and the final velocity and time shows you the triangle. So you can see that the s or the displacement is equals to area of rectangle plus area of triangle, where s is equals to ut plus t upon 2 and bracket open, final velocity minus initial velocity bracket close. Okay, and to you just make understanding very deep because these are the four basic formulas written at the last. So this is very easier for you to just use and are also given in the paper. Okay, so s is equals to bracket open, initial velocity plus final velocity upon 2 bracket close multiply by t or the time. Okay, where the s is equals to displacement, the u is equals to initial velocity, v is equals to final velocity, t is equals to time, and as a is equals to acceleration. All right, the other value is v is equals to u plus at, s is equals to ut plus 1 upon 2 at and square. Okay, it means that whatever value of t or the time is given to you, you are required to just double it. V square is equals to u square plus 2as, where a means acceleration and s means displacement. In summary, okay, now this is very essential for you guys. In summary, when an object is moving at from acceleration, you can use the following formulas. These are the four formulas, or I would like to just say that these are the five formulas. How it is 5? Because a is equals to v upon v minus u upon t. It means acceleration is equals to final velocity minus initial velocity upon time. So this is also the formula you have already acknowledged from your O levels, from where these four formulas are being derived. Okay, whereas the displacement u is equals to initial velocity, v is equals to final velocity, a is equals to acceleration, and t is equals to. When approaching questions which require the use of these formula, it is useful to write out the values, you know, the and the one and the ones you want to find out in order to more easily choose the correct formula to use. Okay, it means that for suppose you're required to just having given the value of distance, oh sorry, displacement and acceleration is given to you, the final or the initial velocity is given to you, and what is required to find. So you're required to just from make the data. In the data you are required to make s, u, v and a and t. Okay, if s is not given to you, neither it is asked, so you can just cross it, but most usually it is given to you because in every most equation you can see above, with exception of first equation, you can see that s is given in the other three equations or the formulas. Okay, and if the v is not given to you and required to just find out the v, you can use the first formula or the fourth formula or the last formula. Okay, if u is not given to you, neither it is asked, so you can just cross it out, but most usually u is given as required stationary, means at rest. At rest it means that u is equals to 0 meter per second square. Okay, so this will be understanding later. Okay, now this is the question given to you. Okay, just read this question. A stone is dropped from a bridge 50 meters above the water below. What will be its final velocity v, and for how long does it fall? Means now the time and velocity is been asked from you, and what is given to you? In meter, what is given to you? It is the displacement is given to you. Okay. Now just see that note in this example. Okay, now just see that s is given to you, means displacement was 50 meters and u is equals to 0 meter per second. How can you say that u or the initial velocity is 0 meter per second? Because it was in the you can just focus. A stone is dropped from a bridge 50 meters above the water below. Whenever it is said to you guys to find out the final velocity and the initial velocity is not given to you, either it is written in the stationary or a bit logical, so just use your mind and just see that the initial velocity must be 0, means it must be on the rest. Okay, final velocity is equals to question mark because it is asked from you. If nothing is if no of the either this of the value is not asked from you, you can just make a simple cross. A is equals to 9.81. Okay, meter per second square. It means that acceleration. Okay, also because the stone is dropped, we know its acceleration will be g or the gravity, which is 9.81 meter per second square, which is the acceleration due to the gravity. Okay, and the t is asked from you. Okay, so now you can use the value v square is equals to u square plus 2as, because in this you can see that t is not given to you in this formula, the t is not written, so it is very easier for you to find out the v. Okay, and now the question is the first value v is equals to u plus at. You obviously cannot use it because you does not even know the value of t. Yeah, once you know the value of t, so I will just say that yeah, you can use it, but if t was given, I can say that you can use both of these formulas. You can find v. Okay, so the value for v square v is 31.3 meter per second. So this is a value for v. Now you can use any of the formula suitable for you guys, as the answer is same, but I hope so that you must use the easy formula, or either you can use any formula. I do not want to just, but means while the answer is same. Okay, using s is equals to ut plus a t square upon 2. Okay, now you can find t to just make the t subject, and you can find 3.19 seconds. Okay, moving towards the next. You can find the value of g or the acceleration due to gravity experimentally, and below is a method you could follow. Set up the apparatus, okay, as shown in the diagram, connecting the light gates to a data logger and as close to the electromagnet as possible. The position of the lower light gate should be adjusted such that the height is 0.75 meter measured using the meter rule. Turn on the electromagnet and attach the ball bearing. Switch off the electromagnet and note the time taken for bearing to fall between the light gates as recorded by the data logger. Reduce the height by 0.05 meter by moving the lower light gate upwards, and repeat the above two steps, reducing height by 0.05 meter each time down to 0.25 meter. Repeat the experiment twice more to find mean values of t for each value of height. As you can see in the diagram, it's been show you clearly. Okay, so do not worry, this will be also understanding in the A levels. A as practical will be also understanding many of the practicals or the experiments, which is, I know it's not clarified to you, but will be clarified to you in the AS experiments. In the above investigation, the acceleration g is constant, meaning one of the constant acceleration equation can be used to analyze the result. Consider s is equals to ut plus 1 to at square. The displacement of the ball bearing s will be height. Its initial velocity u is 0 and its acceleration is g, means 9.81. So the above equation becomes h is equals to 1 upon 2 g2 square. Okay, 2h is equals to gt square, where obviously, okay, where you can see that at the side of acceleration the g is given to you, and from the side of displacement the height is given to you. All right, therefore if you plot a graph of two height against the mean value of t square, its gradient will be g. Okay, I'm moving towards the last thing, which is when an object is moving at a constant velocity in one direction and experiences a uniform acceleration in the perpendicular direction, it will follow a parabolic shape as shown in the diagram to the right. At first, the object only experiences a horizontal velocity Vx. However, as time goes on, its vertical velocity Vy increases due to the uniform acceleration. This causes the object to change direction, and as the time passed increases, the degree by which the direction has changed increases, as shown by the parabolic shape. Alright, just wait a minute. Yep. Now what is trying to explain you is that one more thing is horizontal velocity and the vertical velocity. What does this means? Basically, when you can see that this is the parabolic shape, or what we can consider in the simple words a simple ball. I will let you just say it a ball. So the uniform velocity Vx, here you can see that the uniform velocity Vx and the Vy, the horizontal velocity, sorry, the vertical velocity, and the, okay, so in the ball, wait a minute, in the ball you can see that the uniform velocity is considered as Vx, okay, and the uniform velocity is also the horizontal velocity, which is also explained from the Vx. It means that when Vx at the first ball, you can see that the Vx or the horizontal velocity is uniform. It means that it is constant, okay, and as it moves downwards you can see that the V, okay, so vertical velocity and the horizontal velocity increases, and as the ball moves more lower, you can see that the velocity of horizontal and vertical must also be increased. All right, this causes the object to change direction, and as the time pass increases, the degree by which the direction has changed increases, as shown by the parabolic shape. Do not worry that this will be also understanding in the next upcoming chapters, and I'll be just making the diagrams for understanding more clearly, clarifying you guys. Okay, so till that, it's here the kinematics and the basic terminologies, the four formulas which have been given to you and their A levels. These formulas are also be written at the back or maybe given you in an extra sheet, and your record just derive the formula, and it is all about the derivation. Okay, plus, what are the base SI units? So we have not discussed yet in this chapter about the SI units, as in this PDF the SI unit does not exist, but in the kinematics it does. So we'll be understanding in the dynamics. Dynamics are our next upcoming live session, where we'll be discussing about the SI base units also, that how to derive the formula. plus how to derive the SI unit. You must be able to know about the SI unit and the formula derivations in your AS physics. It will be very helpful for you in your A levels and in your AS levels for both. Okay, so till that it's here, and I hope so that everything is clear to you. If anything is not clear to you, you can message me or you can comment me in the section. Until that, subscribe to the channel. Do not forget to click the bell icon for the upcoming updates in the next live session, which is dynamics. Take care.